Hello students, welcome to Time classes. In this short session, we discuss about cell notations or cell representations of electrochemical cells in the electrochemistry chapter. Let's start the session. Cell notations or cell representations. IUPAC conventions for the cell notations and cell representations. The term IUPAC convention refers the International Union of Pure and Applied Chemistry. This IUPAC system proposes a systematic set of rules for the simplified representation of electrochemical cells to avoid the necessity of drawing the cell diagram every time. What are the rules? Let's see. In the electrochemical cell, two half cells are there. One is oxidation half cell, other one is reduction half cell. Oxidation half cell is considered as anode. Reduction half cell is called cathode. Means at anode always oxidation reaction take place. At cathode always reduction reaction take place. So in the galvanic cell, zinc electrode is an anode. In this anode, by losing of two electrons, zinc oxidizes to Zn2 plus ion. Okay, next. Anode is taken in the galvanic cell, anode is taken in the left side and cathode is taken in the right side. So copper electrode act as a cathode. In this case, Cu2 plus ions gain the two electrons and deposit as copper on this electrode. So at anode, oxidation take place. At cathode, reduction will take place. So reducing reaction take place at cathode, oxidation reaction take place at anode. In the cell notation of this electrochemical cell, anode is conventionally placed at left hand side and cathode is placed at right hand side. Anode conventionally placed at left, cathode is placed at right. Next, both anode and cathode, two half cells, are separated by salt bridge. It is represented by two vertical double lines. Next, in the half cells, the phase changes are separated by single vertical line or semicolon or by commas. For example, solid phase and solution phase to be separate, we use vertical line. For example, zinc, solid, oxidized to Zn2 plus. This is in aqueous state. Solid and solution both are separated by vertical line, single vertical line. Next, gas and solution separated by single vertical line. For example, hydrogen gas and H plus ion is an electrolyte, that is an aqueous solution. HCl also you get it. Hydrogen and HCl separated by a single vertical line. Next, two solutions separated by semicolon or comma. For example, Fe2 plus ion and Fe3 plus ion. Both are in aqueous solution separated by comma, or semicolon. Next, two solids are there in the half cell. They are separated by the comma. For example, silver solid and silver chloride. Both are separated by comma. Another one, gas and solid also separated by single vertical line. For example, platinum is used as a inert electrode. We use in inert electrode in gaseous electrodes and non-metal electrodes, and in metal insoluble electrodes. So platinum is a solid and hydrogen is a gas. Both are separated by uh, vertical line, single vertical line, that you can remember. Okay, na? Right. Next, physical states, concentrations, partial pressures of species are right in a small bracket. Physical states, concentration and partial pressures of species are written in a small brackets. Molar concentrations, partial pressures in if it is in atmosphere pressure, or if it is in millimeters of mercury. Okay, those pressures are written in small bracket. Concentrations here, molar concentration, 1 molar concentration, 2 molar concentrations, etc. That you can say. If physical state, if you see a solid state, here if it is in aqueous state, okay, or liquid state, you have to mention in a small bracket. Next, wherever the inert electrodes, platinum and graphite, etc., are used in the cell, must show in the cell notation. Generally, inert electrodes like platinum and graphite used in gaseous electrodes, non-metal electrodes, metal insoluble electrodes also. So those inert electrodes must write in the cell notation. Next, while you are writing the cell notation, balancing of the species are not required. So these are the rules. Now we discuss some examples. If two metal ion electrodes are connected in the cell. For example, I have taken a galvanic cell. In this galvanic cell here, this left hand side is an anode. In this anode, oxidation reaction take place. Oxidation reaction will take place. What type of reaction here? Zinc oxidized to Zn2 plus ion, aqueous, by losing of electrons. This is an reaction. This is a reaction take place at anode. Next, this one is a cathode, which is on right side. At cathode, always reducing reaction take place. Okay, so what is a cathode reaction at cathode here? Cu2 plus ion gain the 2 electrons and deposit copper at the electrode. So in the galvanic cell, Zn2 plus ion, standard zinc sulfate solution is taken where the concentration is 1 molar. Copper sulfate concentration is also 1 molar. So now you write overall cell reaction Zn S plus Cu2 plus ion. It is in aqueous state where the concentration is taken molar. Next, it is zinc oxidized to Zn2 plus here, and here the concentration of the solution is 1 molar and Cu2 plus ion is reduced to copper. This is overall cell reaction. So while you are notating the cell, compulsory, first anode is kept left side conventionally, and the right side here cathode is anode kept on left side, cathode is kept on right hand side, and two electrodes are separated by two vertical parallel double lines. This is called salt bridge. Now anode, you see oxidation will take place. So what you can write here? So zinc solid, zinc is oxidized to Zn2 plus. It is in aqueous state. Solid and aqueous solution separated by a single vertical line. Concentration of Zn2 plus ion is mentioned in small bracket, that is 1 molar. Next, two vertical parallel lines. Next, cathode Cu2 plus ion. It is in aqueous state. Concentration should mention in small brackets, that is 1 molar. Next, a single vertical line which separates the aqueous solution and solid copper. Solid copper. This is a cell notation. Left hand side is an anode, right hand side is a cathode. Next, if gas electrode and metal ion electrode are in the cell. In this one here, hydrogen oxidation state is 0. It is oxidized to H plus ion. In this case here, oxidation state of hydrogen changes from 0 to plus 1. So oxidation state is increasing. Therefore, it is called oxidation reaction. Oxidation state. Increasing of oxidation state is called oxidation. This oxidation reaction takes place at anode only. Next, Cu2 plus ion. Copper oxidation state is plus 2. Here, copper oxidation state changes from plus 2 to 0. So, plus 2 to 0, decreasing of oxidation state is called reduction. The reduction reaction takes place at cathode only. Now you have to write the cell notation. In the cell notation, for left hand side anode is there and right hand side cathode is there. Both the electrodes are connected with are separated by two vertical parallel lines. Now anode reaction, if you see here hydrogen is in gas state. Okay, pressure is given here 1 atmosphere mentioned in a small bracket. The next H plus ion mention its physical state. Concentration of H plus ion is C is equal to 1 molar. So 1 molar and two vertical parallel lines. And cathode notation, if you see Cu2 plus ion aqueous state, concentration is 1 molar, single vertical line, and copper is solid. Aqueous and solid phases are separated by single vertical line. Their concentrations, pressures are mentioned in small brackets adjacent to their species. Now, in hydrogen gas electrode here, generally we use inert electrode. So, platinum is used as a inert electrode. Okay, na? Solid and gas separated by a single vertical line. This is a cell notation for this electrochemical cell. Next, if gas electrode and metal insoluble electrodes are in the cell, so gas electrode and metal insoluble electrodes are connected in a electrochemical cell. Now what is happening here? Here hydrogen gas is oxidized, where the oxidation state changes from 0 to plus 1. Oxidation state changes from 0 to plus 1. Increasing of oxidation state is called oxidation. Oxidation takes place at anode. Next, Ag plus ion. Ag plus ion is reduced to silver. So this one is called reduction. Here oxidation state changing from plus 1 to 0. So this is decreasing of oxidation state is called reduction. Reduction take place at cathode. At cathode. At cathode. Now you see both cathode and anode separated by two vertical parallel lines. So gaseous electrode is at left hand side taken as anode. So hydrogen gas pressure is given 1 atmosphere mentioned in a small bracket, single vertical line, H plus ion, mention its physical state aqueous, concentration 1 molar. Here in the gaseous electrode, inert electrode, platinum is taken. Platinum and hydrogen gas separated by single vertical line. The next two vertical parallel lines taken as salvage. Next one is what here? Here Cl minus ion, electrolyte. This is aqueous state and its concentration is 1 molar. It is connected to silver chloride insoluble salt, and this salt is connected to silver salt. Now you observe clearly here in this metal insoluble salt here, metal insoluble salt here. Here a silver wire is there. This is a silver wire. It is coated with a silver chloride insoluble. It is coated with silver chloride. Okay. Next, immerse in KCl solution. Now observe here. This is a silver solid and this one is a AgCl insoluble salt and this one is a KCl aqueous solution where the concentration is given 1 molar. So is insoluble AgCl salt connected with aqueous KCl solution and silver solid wire is coated with the silver chloride salt. Now you write here KCl means Cl minus ion. It is in aqueous state. Concentration is 1 molar. It is connected to AgCl. AgCl insoluble salt is connected to silver solid. Right. This is called silver chloride insoluble electrode. This one act as a cathode and hydrogen electrode taken as anode. This is a cell notation. Next, if two gas electrodes with same electrolyte of different concentrations are connected in the cell. Observe here, both are gaseous electrodes, same electrolyte with different concentration. So both are hydrogen gas electrodes only, but their electrolytes are at different concentrations. Here hydrogen gas oxidized to H plus ion. Here oxidation state is changing from 0 to plus 1. Increasing of oxidation state is called oxidation. Oxidation take place at anode. So conventionally in the cell notation, anode is kept on left side, cathode is kept on right side. Now here H plus ion reduced to H2. So oxidation state is changing plus 1 to 0. Decreasing of oxidation state. Therefore, reducing reaction take place. Reducing reaction take place at cathode. Point to understand. Both anode and cathode separated by two vertical parallel lines. Now, first we have to write anode. Here, hydrogen. Anode reaction you see here. Anode reaction hydrogen losing of 2 electrons, releases 2 electrons and oxidizes to H plus ion. Oxidation state here 2H plus ion, aqueous state, concentration is C2. Next cathode reaction, if you see 2 H plus ion, it is in aqueous state, its concentration is what? C1 concentration. By gaining of 2 electrons, reduced to hydrogen gas. Hydrogen gas. Here hydrogen gas pressure is P1. Here hydrogen gas pressure is P2 atmosphere. P2 atmosphere. Overall cell reaction is this one only. Now anode you have to write. Anode you have to notate. First H2 gas. Pressure P1 atmosphere. Anode I am writing this one. Okay. Then single vertical line. The next H plus ion balancing is not required. Mention its physical state and its concentration. Here in this gaseous electrode compulsory platinum is used as a inert electrode separated with a single vertical line. Next 2 parallel vertical lines, that is a salt bridge. The next H plus ion, its concentration is C1. The next single vertical line, next hydrogen gas and mention its physical state, gaseous state and its physical state P2 atmosphere in small bracket. So this is considered as anode, this one is considered as cathode. Both are connected with a salt bridge. This is a cell notation. Okay. Next, if 2 gas electrodes with same electrolyte of same concentration are connected in the cell. For example, you see H2 gas, its P1 atmosphere gives H2 gas P2 atmosphere. This is an overall cell reaction what he has given. Now you have to write anode reaction. At anode what is happening here? Hydrogen gas. Its pressure is what? P1 atmosphere. It is oxidized to 2H plus. It is in aqueous state. Here by losing of 2 electrons. Assume here the concentration is 1 molar. Let's assume 1 molar concentration of this H plus ion. Next, at cathode 2 H plus ion. It is in aqueous state and its concentration is also 1 molar. By gaining of 2 electrons gives rise H2 gas, and its pressure is what? P2 atmosphere. Overall cell reaction, if you write 2 H plus ions get cancelled, 2 electrons get cancelled, H2 gas P1 atmosphere gives rise H2 gas P2 atmosphere. Now you write the cell notation. Well, how can you write here? First H2 gas, measure so what is it? Write its pressure in small bracket P1 atmosphere. Next H plus ion, aqueous, its concentration I have taken as 1 molar. Okay, then 2 vertical lines. Again H plus ion, mention its aqueous physical state and mention its concentration in small bracket. Then next single vertical line, hydrogen gas and its pressure in small bracket, that is P2 atmosphere. Here in both cases here platinum is used as a inert electrode, that you have to be mentioned compulsory. You have to note, right? Okay, but in this case here you observe clearly, in this case these two are same electrolytes, same concentration. So this cell can be notated in this way. Both are having same electrolyte with same concentration. So it can be denoted in this way also. Same electrolyte. So left hand side to this same electrolyte here, Pt solid state, hydrogen physical state is gas, pressure P1 atmosphere. It can be written in this way also. Here H2 gas, mention its pressure here P2 atmosphere. The next platinum solid. So this is also one of the way and simple way you can notate this cell. Next, if two metal insoluble electrodes are connected in the cell, this is overall cell reaction. AgCl plus I minus gives rise AgI solid plus Cl minus aqueous. So here oxidation state of silver is +1. Here also +1. So nowhere connection is there. Here what I am doing here? On reactant and product side, both sides, I am adding silver solid. I am adding silver solid. Here charges are balanced. Charges will be balanced, never change, because oxidation state of silver in elemental state is 0. Now observe clearly. Silver is get oxidized to AgI. Your oxidation state changes from 0 to +1. Increasing of oxidation state is called oxidation. So oxidation reaction take place at anode. Next, Ag plus ion reduce to silver. So +1 oxidation state changes to 0. Decreasing of oxidation state is called reduction. Reduction reaction take place at cathode. Now you write anode reaction. Ag solid. Here it is oxidized to Ag plus electron, losing of electron. Here charges to be balanced. Here if you observe here Ag plus is there, here it is Agi now. So this is I minus. So on the left hand side also you have to write I minus. This is in aqueous state. Now here charges are also balanced. Here one electron is there. Here I plus I minus I, balance. Okay, na? This is anode reaction. Whereas a cathode reaction, if you see, cathode reaction. Here Ag plus, by gaining of an electron. What is forming here? Silver solid is forming. Here I am just writing Cl minus. So on the right hand side also I am writing here Cl minus, aqueous. Now here charges are also balanced. So this is an anode, this one is a cathode. Overall reaction, if you write here I minus, what is that? Electron get cancelled. Electron get cancelled. Silver get cancelled. AgCl, I minus, AgI, Cl minus ion only is there. Okay, now overall reaction, if you write this silver get cancelled, electron get cancelled. So AgCl, I minus, AgI, Cl minus ion only present in the overall reaction. Now cell notation you have to write. These two are metal insoluble electrodes. One is cathode, another one is anode. So anode on the left hand side. So what you have to write here? Silver solid. Okay, it is connected with it is oxidized now, AgI. Sorry. The next, it is connected with I minus, aqueous. Okay, aqueous. Then two vertical parallel lines, solvation. Next, here Cl minus ion you are adding, aqueous. Cl minus ion, electrolyte connected to AgCl, that is solid, and this is connected to silver wire, this one. So this is a cell notation of this electrochemicals. This is the way you have to know. Next, write the cell notation for the given reaction. 2Fe2 plus aqueous, its concentration is C1, and Cu2 plus ion, its concentration is C2, gives rise Fe3 plus 2Fe3 plus C. This is overall cell reaction. In this one here, oxidation state of Fe2 plus ion is increasing. Oxidation state of iron increased from +2 to +3. Increasing of oxidation state is called oxidation. Oxidation reaction take place at anode. Next, Cu2 plus ion reduced to copper. So +2 oxidation state decreased to 0. Decreasing of oxidation state is called reduction. Reduction reaction take place at cathode. Now anode on left side, cathode should be written in right hand side. Both are connected, are separated by two vertical parallel lines. Left hand side anode you have to write. Now you see, in the electrolyte Fe2 plus ion is there, its aqueous state is in aqueous state, its concentration is C1, mentioned in small bracket. Fe2 plus ion in aqueous state and Fe3 plus ion is also in aqueous state. Anode reaction, Fe2 plus to Fe3 plus, it is also in aqueous state. Okay, na? Both ions are in aqueous state only in the electrolyte. And if two solutions are there in the electrolyte here, compulsory you have to use a solid electrode, that is inert electrode, separated by single vertical line. Next, Cu2 plus ion, mention its physical state, aqueous, concentration is C2, vertical line. Then next, copper. This is a cell notation of this reaction. Next, write the cell notation for the given reaction. In this one, cerium 3 plus ion oxidized to cerium 4 plus, Ce3 plus oxidized to Ce plus 4. So plus 3 changes to plus 4. I am not balancing here, only I am just changing of oxidation state until. Increasing of oxidation state is called oxidation. Oxidation reaction take place at anode. Now at cathode, if you see, here oxidation state of chromium, you have to observe. Chromium oxidation state in Cr2O7 2 minus, that is +6. So here oxidation state is changing +6 to +3. So decreasing of oxidation state, here balancing of charges is not required here while you are notating the cell. Okay, now +6 is decreasing to +3. So decreasing of oxidation state is called reduction. Reduction reaction take place at cathode. Now first you have to write anode. At anode here, cerium 3 plus ion, and mention its physical state. Its concentration is 2 molar. Okay, na? It is oxidized to cerium 4 plus. Its oxidation state is 4 plus, aqueous state, and its concentration is 1 molar, where he has given 1 molar. Okay, na? So in this one, we use inert electrode, that is platinum. Next, two vertical parallel lines. Now what is happening here? Here Cr2O7 2 minus reduced to Cr3 plus. Here acidic medium is added to dichromate ion. So that what you have to write here, Cr3 plus first you have to write. Mention its physical state, that is in aqueous, and its concentration 1 molar. Then next, comma, Cr2O7 2 minus. Mention its physical state, aqueous, and concentration 2 molar, what is given in the reaction, and adding of acidic medium, H plus Ar. Okay, na? It is also in aqueous state. Concentration here 1 molar. And you have to use inert electrode, that is platinum. Oxidation, what is the physical state is solid. Single vertical line. So this is a cell notation of this reaction. Just check it out. Next, write the cell notation for the given reaction. In this one here, two gaseous electrodes are taken. One is hydrogen electrode, other one is non-metal electrode. Here oxidation state of hydrogen is 0. It is oxidized to H plus Ar. So what is happening here? 0 to plus 1. Oxidation state is increasing. So oxidation take place at anode. Next, chlorine. Check it out here. Oxidation state is 0. So 0 to Cl minus N. So oxidation state is changing from 0 to minus 1. Decreasing of oxidation state is called reduction. Reduction reaction take place at cathode. Both are gaseous electrodes. So you have to use inert electrodes. Now you see here hydrogen oxidizing now. Pressure is P1 atmosphere. You have to mention its pressure, partial pressure. Then next vertical line H plus ion. Mention its physical state aqueous. Concentration is 1 molar. Okay, and here you have to mention inert electrode. Platinum is solid, separated by single vertical line. Next, two vertical parallel lines, that is a salt bridge. Then after here, Cl2 to Cl minus you should not write here. Here you have to write Cl minus. Okay, Cl minus aqueous. Oxidation state here it is Cl minus here. Concentration is 2 molar. Okay, and Cl2. Here it is connected with the inert electrode. Sorry, this is a non-metal electrode. While you are notating the non-metals here, Cl minus ion to Cl2 you have to write, not Cl2 to Cl minus. Cl minus to Cl2. Okay, na? Here we use here platinum plate is a inert electrode. This is a cell notation of this reaction. Next, write the cell reaction for the given cell. In this one here, left hand side is anode, right hand side is a cathode. So first you have to, this is a hydrogen oxygen electrode. Hydrogen oxygen electrode here. So anode, if you see, hydrogen is gaseous state. Mention its physical state is gas, and what is that? Pressure, partial pressure is 1 atmosphere. Now what is happening here? By losing of electrons, it is oxidized to H plus ion. Electron, by losing of electron, it is oxidized to H plus ion. Later on we balance that one. Okay, next anode reaction you see. Here this reaction take place in presence of acidic medium. So that O2 is a gaseous state. It is in gaseous state. Okay, so here what is happening here? It is reduced to what? Reduced to water by losing of electrons. Here two oxygen atoms now. So 2 H2O. It is in liquid state. So 2 H plus ions. So 1 oxygen, 2 electrons. So total 2 oxygen atoms are reduced to O2 minus ion. So total 4 electron it has to lose. It has to gain 4 electrons. It has to gain 4 electrons, not losing. Gaining of electron is reduction. So oxygen 0 to minus 2. 1 oxygen atom 0 to minus 2. Total 2 oxygen atoms. So 0 to 2 into minus 2. So that 0 to minus 4 is what? 4 electrons. 4 electrons are gaining. Okay, na? 4 electrons are gaining and in presence of acidic medium. So that here you have to write 4 4H plus ion. So here also you see 2H2 4H plus ion. It is in aqueous state. It is in aqueous state. Here 4 electrons. Overall cell reaction if you write here 4 electrons get cancelled. 4H plus ion, 4H plus ion get cancelled. Now overall reaction if you write 2H2 gas plus O2 gas gives rise to H2O. This is hydrogen oxygen electrode. Here pressure is mentioned, P is equal to 1 atmosphere. Pressure is mentioned. That is, this is a overall cell reaction. So these are the questions so far we discussed in this session. I hope you understand cell notations and their representations of different electrochemical cells. Thank you.